All right, that should be up and running. Hi, everyone. Thanks for joining. Um, how are we all doing today? It is a cold day in Seattle. I think the low is 32 degrees Fahrenheit, so 0 Celsius. That's the one conversion I know how to do between Celsius and Fahrenheit is freezing. um, but yeah, we should have some good skiing soon, hopefully. Cold and drizzling in Washington, D.C. I think I would expect that on the East Coast. Perfect. So, Sheer, what's it like in Israel right now? Like in November?
Actually, weather's great. So yeah, it's kind of the last time where it's you can still walk around without like real sweatshirts and stuff.
Oh, nice. Yeah, we lost that privilege already.
Yeah, but then we don't have the skiing part, so
Oh, you don't have the skiing part. Yeah, so where do you travel to? Or well, first, does Israel have indoor skiing? Because I've seen those popping up in places that are more of a desert climate, and I've always wanted to try it. I don't know what it would be like, but
there is like that. There's something called like a skimulator, which is it's like an indoor kind of like a walking pad, but for skiing. Which is quite cool. And there is a very small kind of synthetic skiing up in the north, but it's not very well developed. So
yeah. So where do you travel then when you go skiing?
Personally, usually France. So I've just recently received a link describing the great powder in Japan. So maybe I should check that one out.
I have heard great things about skiing in Japan. I've never skied in Japan. I've always wanted to. I had a friend in college that went and did it, and he came back and said it was unbelievable. So that is a goal of mine one day to go ski some powder in Japan. And I think it's funny. Someone's describing the weather in India as sneezy. I think that's funny.
Sao Paulo, nice.
Yeah, not cold in Sao Paulo. Anyways, we'll get started here in about a minute, everyone. So while we wait for that, I am going to make a couple of announcements. So first, for Q&A, we are going to be answering questions throughout the webinar. So just ask your question as it comes to you, and we'll try to get to it. Sheer is going to be keeping an eye on everything, as well as myself, so that we can make sure to answer questions when they're relevant within the presentation. If you're in Zoom with me, use the Q&A tab. It's just easier for us to keep things organized. If you're on a live stream, just ask your questions in whatever chat you have available to you, and we will pull them into Zoom for you. At the end of the webinar, if you are on Zoom, we're going to try kind of giving people a live mic to ask questions if they want to. So if you can just raise your hand, I can give you a microphone access, and then you can ask your question. If you don't feel comfortable, talking with your voice on a recorded live webinar, don't worry about it. Just ask your question in the Q&A tab, and we'll read it out for you and get that answered. And then was that everything? I think that was all the announcements I had. This will be recorded. I know this always gets asked, so I'm going to answer it now. This will be recorded, and we will share it after we edit out any awkward silences or anything like that. So it'll be up on Data Science Dojo's website, on our YouTube channel, and I think we're going to also try and get it on Sheer's YouTube channel as well, right? We're going to try that. So
on Deepchecks is one. Yeah.
On Deepchecks, sorry. Yeah, on Deepchecks. So with that, Sheer, we're really excited to have you. We're going to be talking about how to validate our models and data easily and avoid any common machine learning pitfalls. So Sheer, co-founder and CTO of Deepchecks, why don't you go ahead and get started, maybe introduce yourself a little more, and then I will just kind of fade into the background, and you will only hear from me if we have questions.
Sure, sounds great. And happy to be here this evening, morning, or wherever you are and what time it is. So this is a topic I really love talking about because it's very close to my heart as a data scientist and seeing many different types of problems in models, data, and knowing that I could have avoided them much earlier. And after kind of facing these types of things in my career, I'm happy to have the opportunity to really both talk about it, think about it, and also work to develop that field. So maybe I'll really introduce myself shortly. So I'm Shir. My original background is in the idea. There's a program called Pitfalls for technological leadership. That's kind of where I started in my first degree, and worked in cyber research initially, and then transitioned on to data science. Worked in the Prime Minister's office, and then as you've mentioned, the co-founder and CTO of Deepchecks. So after working on various data science problems and seeing like the challenges in both their adoption and also like different things we faced during the research and how we could have avoid them, or in general, just like done it more efficiently and methodologically. In Deepchecks, we work on what we called continuous validation for machine learning systems, which is like models and data. And I'll touch that a bit more. And well, except for my professional life, I train not only models, so I love also training in more conventional stuff and also a bit less conventional stuff. And if you wander around Tel Aviv, you may see me also on my electrical or non-electrical unicycle. So we're going to talk a bit about motivation to this field, like what am I talking about? What am I trying to avoid? Why is this so common, problematic, or important? Drill down a bit into what does it mean to validate ML or to test. I will use these terms kind of interchangeably. ML validation is I see, by the way, a raised hand. So ML validation is the kind of the concept of checking it, while testing is what we do in, or ML validation is what we want to do for the model data, and testing is that's the term we usually use to running the various checks. So we're going to see various problems, typical problems, and tips how to avoid them, how to avoid them, and the last part I'll introduce the Deepchecks package, which is a framework, an open source one that you can use for some of these tests, and feel free to run the code alongside, or also if you want later. So those of you that want, you can already kind of have an environment up and running with like just a Python environment, recommended a clean one, and you can install Deepchecks with -u in order to upgrade. If you already have it installed, that will just kind of enable you to more easily run it later on. We'll share a bit later the link, so it'll be just like a Jupyter notebook. And then as long as you have Deepchecks in your system, then you can just like run the cells with me. Cool. So a bit motivation to what we're talking about is, these are just a few kind of public examples to what can happen with machine learning without sufficient validation. Of course, again, these are the things we thought we heard about many times. It's much smaller things that we faced or already solved sometime in our pipeline. Sorry, the raised hands. Okay, yeah, I am kind of looking at the Q&A, so if there's something, feel free to write there. But cool. So these are a few of the public ones. If you want, Fatima, can you please share the link? There's like we have a blog post about various of some of these and some more kind of public ML failures. Yeah, and you can read some more about each of these. Anyway, in general, it's something that we face, and we want to solve or really not reach there. So a bit motivation to what is it like? Why not just, I mean, okay, we want to solve problems. We don't want to have bugs in production. We don't want to like discover them super late in our research process. We want to find them early. So why not just use software testing methodologies? I mean, software development is here for lots of time, and there is lots of testing best practices. And the thing is that it's in some aspects much more challenging to test machine learning. So one thing is that it changes in a very different manner. I mean, in software, we can kind of track our changes and see, have we tested the different things we changed, while in machine learning, it's not that clear what are we tracking and what is actually changing. Another thing is that it's harder to understand how we checked everything. I mean, also in software, like code coverage won't really solve everything, but it does give us some understanding of which use cases we've covered or not. And in machine learning, what are we trying to cover? Is it like the inputs distribution space, or is it the activation of the neural network? So it's really hard to understand how we tested various flows or various edge cases. And one of the, in my opinion, the most troubling or challenging things is that it's super common to have silent failures. So what do I mean? A model will still give the prediction, even though it's given data that is just like not that relevant, whether it's nulls or just something changed, and the number will still be there. We won't know that it won't just like, in many cases, just won't break. So incorporating the kind of the practice of testing is first of all important because of the various challenges of the system, and gives us the potential to improve our model. So many times, like, we may have some type of bug. For example, we have some leakage in the way we split the data. I mean, maybe the model works fine and everything looks okay, but if we actually drill down, we understand that if we would have split the model in a more if we would have planned more and split the data better, then the model performance would be much better. So it's a potential to improve not only our practice as data scientists, but also the actual results. And I think being able to back our models, be more professional, and be more sure of the results and the products that we're delivering is, of course, essential. And I think you'll agree with me that it's important. One thing that we saw is that it's not very common. What do I mean? Many places have various ways of testing manually or inspecting. I mean, probably all of you, when you build a model, you check its performance metrics. But how deeply do you do it? Do you check it in different segments? Do you know that everything in your pipeline worked as you think it is? When the model goes out into production, in what manner do you monitor it? So these are testing, and are continuously validating and testing is quite a wide topic. And it's very hard to cover it elaborately, and it's very rare to see companies that have really kind of adopted all of the workflow. And that is one of the reasons that we believe that it's important to both help incorporate the processes and help build tools to enable that. So when we come to test machine learning models, what do we have? Essentially, it's quite simple, right? We have the data, we have the model that we've built, and we have the process of kind of taking the data, training it, building the model, and of course, some kind of environmental aspects. So whether it's various constraints like business constraints, and whether it's the dynamics of the environment. So for example, if there's a specific trend, for example, due to COVID or different changes just in the system. We'll go over a few examples soon. And in reality, it looks a bit more like this. So this is kind of us understanding that we have to try really planning and thinking, what do we want to test? How can we do this in as a comprehensive and kind of well-built manner as possible. So we'll view some of the challenges in order to understand what are we trying to monitor and look for or test for. So when we talked about the different aspects, we can split it kind of to three phases. First of all, we have the data, and we wonder, is it okay? I mean, do we have any unknown nulls? Do we have maybe data from different data sources, and maybe it's kind of representing the same thing, but it's built completely differently, and we're maybe not aware of it? Maybe we have older samples along with newer samples, and maybe the newer samples have more updated labels that may be conflicting the older samples, and so forth. So does the data represent, or is built the way we think it should, and is it correct? We have data distributions, which is everything that has to do with how does it behave internally? So are there any extreme outliers? Or for example, when we compare different data batches, does it still behave the same? And we have model behavior, which is how the model, any things. Well, these are just kind of a few examples of, in each of these fields, of examples of various problems that we may have. So I gave examples of dirty data and label integrity and of drifts, and in the model behavior, things like overfit or fairness and bias, and we'll see a few practical examples. I'll say in general, I'm going to demonstrate mainly for tabular data. the concepts of what are the types of things that we're trying to catch and that are kind of popular are very, very similar. Many times the algorithms to how to actually implement and check it may be different because, of course, the data is different and we process it differently. If you want, feel free to ask later. I can also give kind of a computer vision example, and that's it. But again, the concepts are the same. And we'll jump into a tabular example. So I have here a sample of a model that is trying to predict whether to approve or not a loan. So we see here things like income, sex, loan amount, and various additional metadata. And the model just gives it's a binary classification. So between 0 and 1, whether to approve or not the model. Now, let's see another sample came down the pipe, and we see here that something changed. So in this case, you see that the only thing that changed is the way that United States is spelled, which may be due to another data source, or just kind of ambiguous spelling, because maybe it's a field that the user just put as input. We may have caught it earlier in the pipeline and kind of made it all the same uniform, but if we haven't, then it's likely that in the processing, the model will kind of treat this as a different category. Obviously, we would expect the model to give the exact same predictions for these two, and in this case, we call this a string mismatch. It's just a small example of small changes that can kind of silently change the way your model behaves and probably make it perform worse than it would have without these kind of problems. And another, maybe more on a different note, an example here is that we see that all of the details are the same except for the sex. And also here we got, in this case, a higher score. And this comes to us thinking about our policy. Is this something we either required or want to check for, monitor, verify? And in this case, obviously, no one will tell us, okay, there are some parameters that you don't want to affect your model. This, by the way, is a very direct one, but many times we won't actually include this as a feature, but we may have other proxy features that are affecting and making various demographic changes to our model's predictions. And many times it's just based on the specific, maybe a sampling bias kind of in the data we've trained on. And these are things, again, that we want to make sure we test as we'd want them to behave and define. To connect this a bit, I want to kind of give a real use case. I'll say that it's real as in it represents the full end-to-end story. I will describe it, all of its phases, and not all of these faults happened on the same project at the same time, but just kind of to give you a more practical feel. So I took many cases that we faced or found in different aspects and kind of put them, joined them to this one project. So to the story of this one project. So we're gonna kind of view a model that is trying to classify for a specific access to a website, whether it's a bot or a human being. This is interesting and relevant because we want to avoid scraping attempts, credit card fraud, and things like that. And there's lots of bot traffic trying to do these types of things. Classically, what will happen is that if it's identified as a bot or potentially a bot, it will be referred, for example, to a CAPTCHA and then on. And well, we wouldn't want to just refer all the traffic there and harm conversion and rates and things like that. So second. Cool. So I'll describe a bit the pipeline of this model. So it's working on data, things like data from the packet of the access, things maybe from the firewall or router. There's a company, let's say a company in the field of cybersecurity and trying to identify this, and has various teams and tools. And in this case, it has various tools both sitting on the web, from the web browser, traffic, firewall, etc. Not firewall, I mean a router. And these all extract data fields, analysts develop, choose them, and they're later on referred to the model. The machine learning team did a train test split, pre-processed the data and everything like that. And after it was deployed to production, so here we have both the research part, and then once the model is already working, ongoing, then it's automatically retrained every time on 8 days, which is nice because it gets twice the weighting of all the samples are weighted equally. or well, not really, it's like oversampled for the like in this case the bot activity, but it's given twice the same day, because sometimes like typical days have in the week have more similar behavior. And it's trained on a very wide data set, both on websites that it was directly trained on, and also some new websites that are also clients of that company. And sounds good, I hope, I think. And still, I mean, what can go wrong, right? It sounds like a great pipeline. So let's look at the different phases. For the different, the data that comes, there was, one of the teams did an API update, and they changed the result of one of the fields from, instead of being between 1 to 3, where 1 was low and 3 was high, to 1 to 5. You can imagine what happens with the model that on one hand continues to work, but on the other hand, like treats the 3 as the highest and so forth. So we still have the same data, but actually representing different values. For the split, when the data science team did it, they didn't notice that even though they had like an identifier of, they knew when the traffic came from the same device or IP, they split some of the like website access was to, you know, in the training data, and the others were in the test data, obviously skewing the results, because if we have that, we may kind of learn on various features that are more relevant to the device, which is usually consistently either a human being or a bot, and so forth. Every time we train it on the past data, but we weren't notified, like, as a data science team, that the marketing has just launched some campaign, like marketing of that company that we're trying to help protect their website. And they're now targeting Android users and promoting a specific product on a specific page. Obviously, this changes very much the performance on the day and the days after the campaign was launched, and kind of, it wasn't yet like, let's say on the second or third day, most of the training data is still much before, but now like we're still likely understanding these new activities as something very different, and maybe like referring more of them than necessary, for example, to a CAPTCHA. And we talked about various websites, some that we know better because we've had them in our training set, and some that we know less. And well, we really don't necessarily know on which of these is it going to behave like more similarly, and therefore the performance will be as we expect it to. And maybe we have some websites from other domains that it just like the typical behavior that we know is super different. And then like maybe we have some websites with very, very bad performance, but if we're just kind of looking overall, we won't necessarily notice it. So looking at all of these together, and again, there are various examples, but all of them actually happened in different projects, we can understand that when we trained our model and retrained it and made everything and, you know, deployed it happily to production, we were super happy with the results, and so was the management. But in real life, things were very, very different, and we received quite a few not so happy phone calls. So let's start testing. Or what do I talk about? What do I mean when I say testing, and how should we start, or what should we think about? This is a kind of introduction in general to how to approach it, and then we're gonna go dig in a bit deeper. So how should we start testing? We have various things. So the inputs of what we actually want to check, like what should be explored, for example, the data or the model, the checks. So what are the types of problem that we're checking for? When do we do it? So in the research, in different phases in the research and production, in between, in all of the above. And methodology of how do we incorporate this in the process. So we're going to talk mainly about the first three and kind of explore each of them. For the methodology part, first of all, I encourage you to ask any specific questions or ideas if you want. It really depends on what is your phase, like what are you working on now? Is it an academic research use case? Are you working in a big company where you already have, for example, CI/CD workflows? And if so, are your data science models incorporated there or not? So obviously for each of the phases, whether it's in research, during deployment, for the decision whether to deploy or not a model, and when the model is already deployed, there are different practices, tools, and kind of best practices to incorporate. And I think that once you have the awareness, tools, and thoughts of what can go wrong, now it's kind of more an act of a decision of actually implementing it. So about the input, so we viewed these different types of problems before, data integrity, distribution, model behavior. And if we look at where these problems occur, or what should we actually inspect, we see three things. So for data integrity and data distributions, it's everything that has to do with the input data, whether it's like the data that we've already trained on, or like new data that's coming in production. Batches is a name for kind of various like different data sets. So for example, if I split my data to train and test, then these are 2 batches. Or if I train my model now, I have new inference data. So I can also treat these 2 as batches and like compare between them. Do I have like drifts or leakages? And everything that has to do with the model, obviously the model is also coupled with the data, because in order to understand, for example, its performance, we want to either run it on this data or on other data, but in order to evaluate, we also use the data. But that's the concept of really like being able to inspect the model's predictions. And so what do we want to check? Here is a very high level list of what are the types of things that can go wrong, like the types of the data, for example, correlation between different features, distribution differences, and model robustness and things like that. This is a part that it is both, I'll say like 2 things. There's quite a long kind of generic list that you can build and elaborate as you go on. So that is one of the tips, and I would recommend you also to check out, like in this case, I'll talk a bit about it later, but in general, like in Deepchecks, you can also just get inspiration for many of the different types of things that you can test for. And I would say that what you really want is, what you want to need is a kind of long list, which is both domain specific. So there may be, some things that are relevant only for you and not general, but there's also a very, very wide kind of general types of problems as you saw before. So the idea is first to know what you want to check and make sure you do it. I will say many of us do this quite naturally, when we do like data exploration, right? We check different things like about our distributions and about the data's integrity, but we don't necessarily then, first of all, we don't necessarily cover everything. And if we would have had a reusable code that, you can just kind of plug and play and run, then it would be much more efficient and also much more elaborate to actually check everything. And also, we usually do it manually and only a singular amount of times, like once or twice, but we probably won't do it every day or on every new batch of data and inspect it manually. So yeah, this is the main tip. Again, this is like super high level list. So from here, I guess you have a list of at least 50 different checks that, you can prioritize accordingly. And moving on to when should we test? So the quick answer is as soon as possible, as early as possible in the pipeline. And if we talk about the pipeline, so we have everything that is done in the research, like the first time before we've even deployed our model, when deploying it, like kind of deciding whether we want to deploy it or not, and also now when it's in production and serving. So in each of these phases, we have the relevant tests that can already be done. So like when monitoring it, it's continuously checking it. But for example, when we started our research, as soon as we already got the first data and we haven't yet even split it, built any model, we really want to extensively check its integrity. And once we start pre-processing and working with it, we may already have like the batches that we can compare and verify. And when we have a model, whether it's like our most initial model or like also after further iterations, that's when we can already kind of inspect, compare, and so forth. And of course, continue probably in both in CI/CD and in monitoring, we would want to inspect the same kind of things that we've checked for before, just kind of together, and also verify whether we should continue working with them or send it back to the research bench. So how to start? I tried to Google this, and no real kind of well-built methodologies or results, because really it's a less established kind of field. And this is one of the things that we have been thinking a lot in Deepchecks, kind of as how should we approach it? What should we check? As I said, like the checklist, what do we run it on? And we're going to now drill down a bit into the structure and then run an example. I'll say in general that like the way we built Deepchecks is a very in a very kind of customizable manner. So the idea for me is, first of all, it's open source, so you're free to try it out and use it. and also to take, ideas. Maybe you want to implement different checks, or like add custom checks, or also use the framework and methodology in whichever way that that matches your form of work and organization. One thing I will say now is that we're going to be like in a few minutes, maybe like 5 minutes, we'll reach the live code example, in which I'll go over a notebook with some data set, and then we'll kind of see how it runs and like explore a few of the checks and things like that. So those of you that want, we have Fatima, if you could send the bit.ly link. It's just a link to a Google Drive where I put both the notebook that I'm going to go over, and also the dataset. The dataset is just downloaded from Kaggle, so you can also just download it from there. Anyway, so that will be in a few minutes. So if you want, like, you can download it, open. I recommend a new virtual environment for Python, install Deepchecks, and then you'll be ready. And also you can just follow me and run it later. So as you wish. Cool. So as I said, Deepchecks is what you see here is a visualization of some of the results. So I'll talk a bit about the structure, how it looks, and how it works. For the presentation, I'm not sure. Maybe I'll be able to upload like a PDF of some of the slides, but I'm not sure I'll be able to share all the PDF of the presentation. Anyway, feel free to take screenshots for specific things if you want. So or you'll also be able to see it by video, so it should be accessible anyway. So what we saw here is a few of the checks, but let's talk about how Deepchecks is built. So we have the main, or the base unit, is called a check. A check has a display, like a check comes to verify a certain issue. So for example, it checks if two similar samples have different labels. Or for example, if there's a drift between two data sets. So that is, every issue will be one check, and the check has both a display value, like the output graphic one many times, and also a result value, which you can process like in code. So for example, the numbers of the actual check. It has a condition. So pass fail warning, or also it has like an optional condition. So you can also just have an exploratory check without a condition. And in order to be able to run many checks efficiently together, we have a concept of a suite. So we have a few built-in suites that you can just run as is, or you can take any combination of checks and build your own kind of test suite. The idea is that in one line of code, you run many checks, and you also receive like the output report. So you can either view it, save it as an HTML, view it in, like if you're using, for example, Jupyter, so you can view it in line, or or export it in various convenient manners. You can check out our docs for more information in general, but I'm kind of explaining the overview. And the way these look GUI-wise is like this. So as I said, every check has an output. In this case, we're seeing a few checks from the computer vision package. So this is something with like inspecting outliers for the labels. That's the check. The condition is just like whether it passed or not for each of the checks. And this is an example of a code, how to build your own custom suite. So just define a few checks and put them basically together. And remember, we saw before like about testing as soon as possible, and data and batches and your model. So that's what we see here. So in order to help you in each of these phases, or at least like a quick start for each of them, we have a built-in suite for encompassing all of the relevant checks for that phase. So for example, data integrity suite runs on only on a data set. The train test validation runs on 2 data sets, and then model evaluation runs on 2 data sets and on the model. So like for the model, you need a model that's able to like supports the kind of scikit-learn API for prediction. That's for the tabular case. Again, of course, for the computer vision, we have also a solution which you can check out. So that's a bit about the structure. If there are any specific questions, we're going to go now to the live code examples. So if there's anything you want to go before, and if not, I'll dive in. So you got before like this link also in the chat. So if you want, feel free to open it, and I'll just launch my browser. Cool. So I hope this is big enough. Maybe I'll zoom in a bit more. Yeah, so those of you that didn't install, you can uncomment this and install. And I'll explain a bit the use case. So remember, we have the data integrity, train test validation, model evaluation. I wanted to work kind of on something completely clean and new. So in this case, I'm going to demonstrate the data integrity suite and a few of its checks on a data set from Kaggle. It's a CDC data set for chronic disease indicators. So it's a very interesting data set. You can use it to explore various risk factors in different topics and areas, and well, build lots of models based on it. And here on purpose, I didn't build any model for a specific purpose, but rather said, okay, I have here an interesting data set that I can explore and build models from for various interesting indications. And let's see kind of out of the box without doing any exploration, what we see or find. Probably if you do it on almost any data set, you'll find various problems. As I mentioned before, by the way, probably in your process as a data scientist when doing exploration, you may find many or maybe even all of these problems. It's first of all, it can also help you also in the initial exploration, and it's also the idea of being sure to cover like lots of the checks, and that's why I thought it could be cool just to run a unprocessed data set and see how it works. Great. So now I downloaded it locally. It's also in the drive folder, and I'm just I think it's like 400K rows. I'm just working here on 10K rows, but Deepchecks runs quickly. You can also run it on more or on all data. Let's just have a look. So in general, the data set has 34 features, and it has different like topics. So for example, and we don't see it here, we have things like alcohol, heart diseases, in different locations around the US, because of the CDC, and with responses so to the different topics. So that's kind of the structure in general, and feel free to check out Kaggle for some more like exploratory notebooks and to learn more about this data set. And let's just see. Okay, so I already said it has 34 features, and well, I loaded 10,000. And these are the different features about the topics, and it's kind of a like question response. So about alcohol, about cardiac stuff, and so forth. Just to have a quick look, I'll zoom out a bit. I hope you see okay, just a bit too big for me. Cool. So this is just a super quick overview about the different types of features. I use this mainly to build this list. So the only thing I need to give in this case to Deepchecks in order to analyze my data set is a bit metadata. Actually, I don't even like for categorical features, I don't even need to supply it. If I won't, it will just infer it automatically. But it's, I mean, if I already know in advance what are the categorical features, then it's more accurate if I just state them explicitly. So I'm just stating them. And also, I saw before, like in the data set, that there are quite a lot of nulls. I'm not sure if, yeah, you can see it here, right? So just saying that if there are any columns in which all of the values are null, so let's drop them. This will be relevant in the future. So I tried doing that. Well, all of my samples are still here, and let's get going. So what I'm doing is importing. This is the phase where we run Deepchecks. Okay, so we loaded the model, we defined the categorical features. If we would have had like a label column, for example, I would have defined its name as well. If I have a date time column, I would also give its name, and same for index and so forth. No, actually, those are the main ones. So categorical features, label, time, and index. You can also see these all here. So if I check out here, you can see what are the various parameters I can give the data set. This is mainly relevant because once you know this metadata, then Deepchecks can use it to analyze better your data set. And some checks run only if you have that. For example, things like time leakage, it will check it out only if I actually have a time column, and now I've defined it explicitly. So we don't know to guess what is your label, for example, if you don't supply it. So in this case, I don't supply a label, and therefore some of the checks won't run. And the data set is just a wrapper object containing the data and the metadata. So that's all I needed to do in order to run. And now I'm gonna run the data integrity suite, as I said. So all of the checks are running in the background, and in a sec we'll kind of see the results. As I said, this is a default suite, so it already comes both with a list of checks, and also almost all of the checks have default conditions on them. So it means that like the different results are already analyzed, and we have some default threshold values, deciding whether we passed or not. So in this case, let's see what didn't pass. Okay, so we have single value in column. So we have some columns that contain a single value. This was like the check condition, feature correlation, and special characters. So let's just dive into the first one for now. Some of them are also related. So it says that there's a list of columns which have only one single unique value. Okay, obviously one single unique value basically means they add no info for me, right? So in this case, maybe if I would have taken all the data set, then it wouldn't have been like that. But in this case, let's say I'm using this actual data set to train the model, and this is not a recommended state. I mean, it's obviously like irrelevant data. Let's try to understand what was the problem. So again, there are a few more checks that I'll show a bit later. But in this case, let's explore this one. And well, there are many more checks that ran as well. So going on to the next check, I did notice before that I have like many nulls, right? So let's see, first of all, what are the, oh, wait, I'll be back here just to show you from where I brought it. So out of the columns, I just took the first column. I said, let's check about that one. And there are additional columns with a single value. And by the way, what I saw the single value is, looks like something empty. Okay, I'm not really sure, but we'll see it in a second. So continuing on, let's see what are the non-nulls values in this. And really, if I'm checking where a response is not null, I see that this is kind of looks empty. So it means all the rest are nulls. And basically what I understand now is that the response field has only nulls and 7 empty strings. Okay, if I want to kind of rerun just the is single, remember I had various columns with that, not only the response one. So let's say I want to like rerun the specific check. In this case, it's called is single value. So the check I just import from checks. I have all the, like in the docs, you can see all the checks and like examples how to run them and their names and so forth. And well, you can also kind of, explore using your the inline and seeing like what completions you can have. So is single value, in order to run a check, just like a suite, I initialize it. I can give it various parameters. You will see it soon. So like a random state, if I'm using sampling, so this is the default. We can also change this to none in order to just use all of the samples. And should I ignore nulls or not? The default is to ignore them, by the way. That kind of explains the result. And in this case, we just see again the result from before. And we can also get it like the value itself. Okay, so here I did like I showed the result, and now I'm running the value, and I can see the number of unique values for each of the fields, for the categorical fields, like those that have relevant, yeah, categorical, or actually checks also for the numeric. Sorry. So for example, year start is a numeric field, and it checks. It just shows the number for each of them. And I can see that I have a few. I'm just trying to extract like the names of all of these columns. Okay. So in this case, these are all the columns with the single. I just wrote list comprehension for receiving their names. And I can see that, okay, all of them have exactly 7 kind of empty ones. And as you remember, this is the shape of my data frame. So for now, what I'm going to do is just understand that this empty string says nothing. It's basically a null value. And I'm just going to fix it by replacing the empty strings with a null. And let's see what happens now. Remember, I did this line before. I said, okay, let's just drop any irrelevant columns that have all null. So I'm checking this out again. And as you can see, in this case, really, those all of those features really dropped because they had only empty strings and nulls. And now I'm continuing with a much smaller data set. So I'm going to show one more check that failed, because if you remember, there were like a few, and then also how to explore a bit of check, and then I'll be happy to show you a bit more additional resources and also answer any questions. So in this case, so I dropped the data on the original data frame, and remember we have the data set. So I want to create a new data set. By the way, I can also just access the data inside. Okay, so this was the original data set, and this is its data. And there's also various additional completions that I can have, columns info, for example, and see like the different columns and so forth. So the dataset itself has various like metadata about the dataset that we describe, and it's all accessible. Anyway, in this case, I want to create a new one because I dropped some of the features, and I can use the built-in copy one. It's just instead of like recreating on defining a new dataset like I did before, I'm just copying the metadata because it's the same. So that's one way I can do it. And okay, this is the new columns info. And I'm running the dataset, the data integrity suite again, and let's have a quick look at the results. So in this case, if you remember before, we had the is single value check failing. So we don't see it failing anymore. We'll probably see it here in the past ones, single value and column. Cool. And what didn't pass? So we have special characters. So let's see what that means. So we have some columns where like most of the samples, many of the samples, sorry, or maybe not that many. We see here what are the amount, like the columns and the amount of only special characters in them. And in this case, like the default condition is that if more than 0.1% of the samples had only special characters, then maybe this is something weird. So that's why, by the way, this one is like warning. It's not an error anyway. We can define like for every problem, if it's an error or a warning, if it fails. So this was one thing, and we can check it out if it's interesting. And the other thing is that we have very high correlation between some of the features. So in this case, we see like lots of features, or actually feature couples with very high correlation. And we see here kind of the correlation matrix. So let's look at this one a bit deeper. You can also, by the way, like just access the result from the suite itself, but I find it more convenient to run the check itself, because then you can also change the parameters. So in this case, again, I see the exact same result. By the way, I have much more features, and like the default display is for a smaller number because we want the display to be convenient. So in this case, what I'm going to now do is rerun this exact same check, just with one of the, as you remember, each of the check has like various parameters. So n samples is how many it runs on, and show n top columns is how many are displayed. So the default is 10. That's why we saw previously 10. Now I just put 24 because that's all I have. Like that's all of the columns. And also I added a condition. So remember that in the suite, like some of the things passed or didn't pass. So in order to actually define that, we have default conditions. So in this case, like there's various, if I do the autocomplete, I can see like what are the conditions I can add. And I added the condition that there are no more than 0 pairs with over 0.7 correlation. And now if I run it, I'll be able to see much more and see, what are the exactly correlated things. For example, year start and year end are totally correlated. Probably they're probably all the same, not necessarily, obviously, but in this case, I think they are. And we can also see some other stuff, like, for example, data value footnote and footnote symbol, or things like every topic has like both a value and also an ID. So so many of them can probably be dropped or kind of combined. So it really depends. And this is more like of a manual process that I will usually just want to make sure that there wasn't a very like severe change, or that that the features that are highly correlated that I'm aware of. And also in this case, like if I want to I can also use the result value, and then it's just a data frame of all the actual values. On the here they're displayed as we wrote in absolute values, whether it's like a positive or negative correlation. And here you have the values themselves, and you can process it and see what are the things that you would want to maybe drop out, like topic ID and topic, location ID, question ID, and so forth. So that was like a brief overview. I will show one thing, that if you go into the docs, like, and you want to try using, I'll show like a good place to start would be in the tabular quick starts. So you have here like the examples for the different suites, like data integrity, which is the one we did now, but just like on a different data set. Train test validation for finding drifts and leakages and model valuation, and also things like how to export the results for an HTML, or how to like create a custom check, a custom suite, and so forth. And here you really have examples for each of the checks, explaining them and showing like how they look, and also an API reference, which can be very useful. For example, if you want to change like specifics of, for example, some check. And of course, you can also always check the sources on GitHub if you want any more like to drill down and or help us fix a bug if you found one. So 1 second, I'll stop. Oh, I won't stop my share screen. I'll just actually move this. So we talked about ML validation and why it's important, how it can help you deal with a challenging system and improve your model and your work as a data scientist or ML engineer. Showed quite a few of the recurring problem types in like both in their titles and also followed through a use case. What should we think about when we started testing? As I said, I didn't really delve into the methodology one, but I have a lot to say about it. What do we want to check? And also, when do we want to check? Obviously, in various phases. And in the research, we kind of delved deeper into that part. So I do want to use this opportunity to say thank you to the data science community. We feel that, and I also want to encourage you to kind of keep contributing your feature requests, and if you have also any ideas, code contributions, documentation contributions, these are things that really vastly help us improve the package and have more ideas, and it's really greatly appreciated, and I'm sure it helped the very quick and wide adoption of the package. Also, if you like what we're doing, I'd love if you can give us a star on GitHub. It's really important for open source initiatives. And yeah, I'd like to thank you. Hopefully, and see you develop more tested and safer models.
All right, thank you so much, Sheer. So before, I know we only have about 10 minutes left for questions. So while people are thinking of those, remember, if you would like to raise your hand, you can. We're going to test out live mics, see how that goes. Otherwise, feel free to throw your question in the Q&A tab. Sheer, we do have a question about any, recommendations you have for books or resources on methodologies. I'm not sure which methodologies this person is referring to, but do you have, for validation, let's say, do you have any recommended resources that you like?
My microphone is fine. Yeah. In general, in the world of software testing, there is like a very wide variety of books and ideas, and I didn't really go into it, like the concept of unit testing and integration testing and how to approach it and when to run it and so forth. That's more kind of the high level one, which I mean, I have some recommendations. I'll be happy to send them over later, but it's also very easy to find those kinds of materials, and they're here for a long time. Specifically in the area of testing machine learning, I think like there's lots of things you can kind of dive into for each of the different challenges, but I don't know to date a very comprehensive one. I do have one example that I'll be happy to, like, I don't have it here, so it'll take me maybe a minute or two to find it, but I have a nice GitHub repo with kind of that connects between concepts of software testing and like how to implement them, like in code. For example, using PyTest and frameworks like that in machine learning, it's somewhere between practicality and kind of theory. So I'll be happy to to send you later the link, Nathan. You can feel free to post it alongside.
And then there's someone named John who wants to compare Deepchecks versus, I think it's DQ. But I don't want to turn this into like a sales call. So John, maybe you can reach out to them individually.
Actually, Nathan, they are all open source tools.
Oh, okay.
So I think it's a question we get quite a lot, and we see them fitting up very nice in the pipeline. So it's not like a competitive company or something like that.
Yeah.
DQ is a AWS tool, and the Great Expectations is also a company. They have a great open source project for data validation. I'll say that the main differences is that both DQ and Great Expectation focus with testing data. So like unit tests for data, and specifically, like, for example, when they talk about data integrity, but specifically in the area of like data integrity in databases, and less so in the context of machine learning. So, they don't have like what is a label or like the fact that these are samples that are then, fit into a model. And therefore, some of our checks are very different. I would say that generally, like those kind of tools would fit in more in the like data engineering pipeline. And once this data is then kind of transitioned to the machine learning phase, then kind of there's like a small overlap. Kind of they come before us, and Deepchecks or any other testing they would do later on is like the next phase.
Okay, and then this question is from Sky. I think Sky is on one of our live streams. So how do you check drift?
Okay, great. Yeah, so a great question, because drift is a very widely discussed topic, and even more so, by the way, in unstructured data, like in both NLP and computer vision. There's quite a wide discussion about like, okay, it's a big field that I can just kind of drop a few words also on that one. Inside drift, first of all, everything is like I do just invite you to check it out in our docs, because we have like various it depends if it's a categorical variable or a numerical one. We have like we use different algorithms for each of them, and we also kind of tune the threshold to to the relevant one when it's like a higher drift. I will send also another link to our checks demo where you can actually see it. So yeah, we just run statistical tests between the two data sets depending on the data type, and that's it.
That's it. Perfect. I'm not seeing any other questions at the moment, but I'll go through our presentation that's going on, or our webinar that's going on tomorrow, and then we'll come back, see if there's any questions that surfaced. So I'm just going to share my screen here really quickly.